Good morning, good afternoon, good evening, whenever you're watching this. My name is Eric Kim, your host of this podcast about engineering and agricultural mechanisms. This is a song that was produced by the country in the 1970s when Korea was in an economical crisis and there were barely any food to eat. So the President Jong Hee Park produced this song to motivate his fellow citizens to work hard to fix the country's problem as a whole. And FYI, Korea at the time of 1970 was so poor that we did not have the technology to mass produce crops. Enough with the song, let's delve into the main point of this video. Humans have always changed the environment around them and made things beneficial to themselves. It was around the early 1900s when the so-called agricultural revolution actually started. At this era, whopping 38% of the people were farmers, whereas in the 2000s, only 3% are farmers. And you may ask yourself, how are we able to produce so much food that our population is still growing? Well, we'll get to that later. Although 38% of the people were farmers, human workforce was a major source of the power in the early 1900s. 38% of farmers were not enough to produce the plethora of food so people can fill their bellies up. However, as technologies developed and machineries came around, people started to use machines to most effectively benefit themselves in agriculture. First machine was ran by a combustion engine used in US factories. It was in the early 1900s. This is when machinery became popular in the country. Furthermore, in the 1920s, people started to water and treat their crops with insecticides by aerial dusting. Aerial dusting was popularly used when people had to deal with large areas of farmlands where people cannot treat the entire area by hand. Pesticides played an important role at this time of history in agriculture. Back in the old days, people had to handpick the harmful insects themselves to prevent their crops from going bad. However, with developed technology, people are able to use insecticides efficiently according to their needs. To handle a farm much bigger in scale, people had to up the strength of their machines using hydraulics. It was first introduced in the 1930s. Hydraulics is a very powerful and cost-efficient way to maneuver and lift heavy things around. Bigger and heavier machines required a much powerful system to move their immense bodies. After a decade or so, the harvesting and spinning cotton became a lot easier due to the manufacturing of the spindle cotton picker that was brought by the agricultural engineers. This technology allowed farmers to expand their farms, harvest and produce at a faster rate, and spend less money on human labor.
Mechanical cotton pickers at work in the Mississippi fields. Planted by seeding machines, sprayed by airplane, this is the first commercial acreage of cotton produced entirely by machinery. The plants are guided by fenders into sharp rotating spindles, which remove the fibers from the plant. Vacuum draws the cotton up into the receiving bin. This cotton picker has proven a highly effective answer to the wartime shortage of hand pickers.
Nowadays, farmers around the world have one of the most advanced technologies around the world to keep producing crops to feed 7 billion people on Earth. Farmers use machines to do everything, from deciding whether to plant which crop, actually planting them, and watering them only the exact amount needed. The computers do all the calculations for them and tell the farmers how much water and insecticides a certain area of the farm needs. This not only decreases the money that the farmers have to use, but also does not pollute the soil as much as it would when farmers spray the entire field with harmful insecticides.
Look past the greenery and you will find a highly technological business where margins are tight, deadlines critical, and global competition fierce. Today, the farmer's best friend is data, which is why agriculture increasingly relies on space. Satellite imagery gives farmers a big picture, so they can understand the layout and composition of their land and optimize planting. Global positioning satellites allow farm vehicles to drive the same routes autonomously, saving fuel and preventing the soil from being needlessly compacted. Satellite instruments can monitor the health of crops over wide areas, letting farmers know which plants need nutrients or pest protection. Farmers then use this information, linking sprayers to GPS, to deliver precise amounts of chemicals only where they're needed. This is better for the ecosystem and cuts production costs. From localized weather reports to soil mapping and crop health, modern farming requires huge amounts of data. Thanks to a new generation of satellites, a vast quantity of information is continuously cascading down to Earth, allowing near real-time changes in the landscape to be observed. All this data presents a unique opportunity. The Catapult is working with a wide range of businesses, helping them develop products and services using space data from the agriculture industry to exploit. Farms are highly mechanized, but often the various machines cannot work together. We're helping to develop sensors and communication devices to allow connectivity across the farm. Gathering and sharing data greatly boosts productivity, so the Catapult is bringing seamless communications into the sector. That means developing shared open-source platforms.
Due to the massive improvement of the technology in agriculture, farmers were able to produce much more food, and it ended up growing the population count. The development of the agricultural technology is the reason why people around the globe are able to feed off of only 3% of the population working as farmers. Machines do the most of the work for farmers, and therefore removing the necessity of the massive amounts of farmers needed to keep the population growing. John Deere Journal states that by the year 2015, the population count will be around 9.7 billion and will require 70% more food production.
Our immediate horizon include autonomous pickers. UK researchers have already created one that gathers strawberries twice as fast as humans. The challenge will be creating robotic pickers that can switch between all kinds of crops. Robots or drones that can precisely remove weeds or shoot them with a targeted spritz of pesticide, using 90% less chemicals than a conventional blanket sprayer. For the organic farmer, they could zap the weeds with a laser instead. This could have a big impact. The UN estimates that each year, between 20 and 40% of global crop yields are destroyed by pests and disease. Tiny sensors and cameras will monitor crop growth and alert farmers on their smartphones if there's a problem or when it's the best time to harvest. The Bonnie Rob can take a soil sample, liquidize it, then analyze its pH and phosphorus levels all in real time. Companies like Agrobotics have already commercialized software that analyzes drone-captured infrared images to spot unhealthy vegetation. Then, like a real-life game of Sim Farmer, the grower is alerted on their device when a troubled area is identified. Machine learning is regularly improving the system's ability to differentiate between varieties of crops and the weeds that threaten them. For an even wider view, Planet Labs operates a fleet of CubeSats that take weekly images of entire farms from space to help monitor crops.
Just imagine how it'll look like 20, 30, or even 50 years later with this fast developing technology. That's it for this video, and thank you for watching.